Hello, advanced geometry students. It's Mr. Donaldson here, welcoming you to another riveting semester of fun and excitement. And to get things started today, we're going to do a little recap from algebra class. I'm going to talk to you about graphing lines and writing equations of lines using the slope-intercept form of an equation, which you guys, I'm sure, did a ton of in Algebra 1. So remember, slope-intercept form of an equation is y is equal to mx plus b. And m represents our slope, and b represents our y-intercept. Remember, the y-intercept is a coordinate. It's a coordinate on the y-axis. And so really, because it's a coordinate, we can express it with an ordered pair. And because it's on the y-axis, it'd be 0, comma, something. All right, and I'll kind of talk to you about that as we go through and look at these examples. All right. Now, before we even begin by graphing these, I think it's really important to point out what an equation represents and how it relates to the graph that you draw. So an easy way to think about this is to think about the equation as a rule. It's a rule that tells me the relationship between x and y. All right, so the first thing I'm going to do is just kind of go back and talk to you about what you learned in algebra class, and then I'll see if I can make that connection between how it's a rule and how the equation is represented by a line. So here's this equation, y equals negative 2x plus 3. Now, I'm hoping you remember in algebra class that the very first thing we're going to do is we're going to plot the y-intercept. So the y-intercept is at the point 0, comma 3. So the two things I want is the slope and the y-intercept. And my y-intercept was at 0, comma 3. And the slope now is negative 2. And I always write the slope as a fraction, because I want to use that rise over run. So I'm going to go for my y-intercept of negative 3, and I'm going to go down 2 and over 1. And I'll go down 2 and over 1 again, and I can do it again. And once you have 2 points, really that's enough for you to draw your line. But I like to do a few, especially on my little program here, to make sure my line is pretty accurate. All right, then you take your straight edge, or try to be as neat as possible, and you'll draw a line that represents this equation. So here's the connection between it. Any point that's on this line satisfies this rule outlined by y equals negative 2x plus 3. And so what I mean by that is you could think that there's an infinite number of solutions to this equation. So here's what I mean by that. Let's take this first order pair, 0, comma 3. Well, if I plug in 0 for x, so here's my equation, y equals negative 2x plus 3. If I plug in 0 for x, negative 2 times 0 plus 3, you'll notice I end up with 3. So that's the relationship. When the x-coordinate is 0, the y-coordinate must be 3. That's what this equation tells me, and that's why 0, comma 3 is an appropriate point to put on my graph. Let's pick one of these other points. How about like 2, negative 1? So when I plug in 2 for x, that's negative 4 plus 3 is negative 1. So that's why the ordered pair 2, negative 1 also fits on that line. So the reason we draw this line is because it is impossible for me to list every single ordered pair solution to this equation. There's an unlimited number of points on this line that would satisfy this equation. So if I asked you to solve an equation like this, x plus 5 is equal to 8, you could just tell me x equals 3 and you'd be done. There's the answer, I'm done, right? But if I want to know all the different order pairs or all the different solutions to this equation, there's an infinite amount. So you couldn't write all of the answers down, and that's why we draw a graph of a line, because any point on this line, any order pair that I can find on this line would satisfy this equation. So just want you to try to make that connection as to why we draw graphs to represent lines, because essentially this graph just shows me every single point, every single ordered pair for x and y that meets this requirement. All right? So, anywho, now that you kind of remember the underlying reason why we draw a graph and remember how to do it, let's just move on and look at another example. Now, in this case, you'll notice that it is not already in y equals mx plus b form. It's not already in slope-intercept form. So what I need to do is I need to tighten this equation up by doing a little bit of algebra to try to get it in this form. So my objective to put it in slope-intercept form is to get y all by itself. So let's do that. First thing I'm going to do is I'm going to distribute that 3. So then I get 3y plus 3 is equal to x minus 3. The next thing I'm going to do is I'm going to subtract 3 from both sides. So I end up with 3y is equal to x minus 6. And then the last thing I need to do to get y by itself is I need to divide everything by 3. Now remember, in terms of coefficients, there's always a coefficient of 1 in front of a variable. So remember that when you're dividing so you can pay close attention to what the slope is. So I end up with y is equal to 1/3 x minus 2. So I've taken my original equation, I've rearranged it using some algebra to get it into slope-intercept form. And now I'm going to identify my slope, and I'm going to identify my y-intercept. The slope is 1/3, and the y-intercept is 0, -2. Oops, -2. So to graph this, I'm going to start at my y-intercept of 0, -2. Then I'll use my slope, the rise over run, to go up 1 and over 3. And if I had more room, I could go up 1 and over 3 again, but I don't. So rather than doing that, I'll go back here, and this time I'll kind of undo it, and I'll go down 1 and to the left 3. So I get 3 points on that line, and now I'm just going to take my straight edge and do the best I can here to draw a line that contains all those points. And remember, the objective here, or I guess the point here, is that any ordered pair anywhere on this line, even this little guy, whatever it is, when I plug in the x and y coordinates, it'll make this equation true. And that's why we graph those lines. All right. Moving on. So then there's a horizontal line. So this represents my horizontal line right here. All right. Now let's think about what the rule would be for a horizontal line. Now first, what's the slope? Now slope is rise over run. So let's just pick any 2 points on this line and rise over run. How much do I go up or down, and then how much I go over? So to go from this point to this point, I go up 0 or down 0, and then I go over 1, 2, 3, 4, 5. So I'm going up 0 and over 5, and 0 divided by 5 is just simply 0. So you'll notice the slope of a horizontal line is just 0, because the rise is 0, and the run is whatever number, really, depending on which 2 points you're using. Now let's think about a rule for this, all right? An equation for a horizontal line. Now check it out. Let's think about all the different ordered pairs. What's this ordered pair? This is at -1, 2, 3, 4, comma 1, 2, 3. So this is at 4, -4, comma 3. All right, this point is at -1, comma 3. And I know it's hard to read my writing, so just really listen. This is at 0, comma 3. This is at 2, comma 3, and 3, comma 3, and 4, comma 3, and 5, comma 3. The point I'm trying to make is that every single one of these ordered pairs has a different x value, but the y value was always 3, because this line, this horizontal line, is 3 above the x-axis. So the rule is simply this. It doesn't matter what the x-coordinate is, the y-coordinate is always 3. So the equation for a horizontal line is always y equals whatever that y-intercept is. So in this case, it's y equals 3. So if I had some, let me draw another one just for a quick example. Let's add a horizontal line right here. Well, then this line would have an equation, because it's horizontal, I know it's just y equals, and this time it goes through -2. So this one would be y equals -2. All right, and let's talk about a vertical line. So again, let's do slope first. So the slope is, I just want to know, how do I go from this point on the line to maybe this point on the line? Well, first I go down 1, 2, 3, 4, 5, 6, and I go over 0. The rise over run is 6. I go down 6 and over 0. Well, look, you guys, in math, you cannot divide by 0. So the slope of this, we say, is undefined. And what that means is that this line doesn't have a slope. It doesn't make sense to talk about the slope of a vertical line. It doesn't exist. So if I ask, what's the slope of a vertical line, you could say, there is no slope, or it's undefined. All right? Now, the next thing is the equation. So what's true about every single point on this line? All right, let's just think about the ordered pairs. This ordered pair is -1, 2, 3, 4, and up 1, 2, 3, 4. So this is -4, 4. This point is -4, 2. This point is 0. Or excuse me, -4, 0. This point is -4, negative 1. This point here is negative 4, negative 5. Again, kind of a similar situation as we noticed over here, but in this case, notice the y coordinates are changing, but the x coordinate maintained negative 4 the whole time, because every single point on this vertical line has an x coordinate of negative 4, which means on a vertical line, the y coordinate is somewhat irrelevant and is not part of the relationship. All that matters is that the x coordinate must always be the same number. So the equation of a vertical line is x equals, and in this case, that x value is negative 4. And again, just like last time, to show you another example, suppose I had like this vertical line. I was like, what's the equation of this vertical line? Well, as soon as you see that it's vertical, you'd be like x equals. And you'd be like, all right, what is the x coordinate of every point? Over 3 up something, over 3 down something. The equation for that line would be x equals 3. So, to recap, horizontal lines have a slope of 0, and the equation is always y equals some number. And that number is the y-intercept. Vertical lines have an undefined slope, and the equation is x equals whatever that x-intercept is. And again, you guys, this is a review, and hopefully that made sense. It kind of brought back the ideas as to why that's the case. But if you have more questions, just let me know. All right, and the last thing we're doing this little notes thing is just write the equations of these lines. And the way we're going to do this, you guys, is just every time we're going to go y equals mx plus b. Except for I'm going to do the easy ones first. And what I mean by the easy ones first is, check this out. This is just a vertical line. This one's just a horizontal line. I'm going to do the vertical line first. Remember what I just showed you. Vertical line is x equals, and the x-intercept is 3. Every single order pair on that line is 3 comma something. That is the equation of that vertical line. This horizontal line, this one's down here. If it's horizontal, it's y equals some number. And that number is, what are all the y coordinates along that line? Well, they're at negative 2. Those are my easy ones. Now I'll go back and use y equals mx plus b for these. So what I need to find is I need to know the slope, and I need to know the y-intercept. So let's do the slope. And the easiest way to do the slope is find 2 points that are on, and I always look for a y-intercept. I'm going to find 2 points that are at the intersection of my grid here. So how about here's a point, and here's a point. So when I'm counting the slope, I always go from left to right. I'm going to do rise over run. So I'm going to go down 3 and over 2. Then I just confirm that that works. Down 3 over 2. There's another point. And then down 3 and over 2. There's another point. So my slope is negative 3/2. And then the y-intercept I found was at this point 0 comma 2. So the equation is simply y equals, slope is negative 3/2. Don't forget the x. Okay, so I plugged in the m. I need my x, and then plus b. The y-intercept in this case is 2. There we go. And then the last one here, same deal. I'm going to follow that same process. I want to find the slope, and I want to find the y-intercept. So let's find the slope first. So here's a point. Let's see. Looks like there's a point. So it looks to me like my slope's going to be up 3 and over 1. Let's confirm it. Up 3 and over 1, that works. Up 3 and over 1, that works. So I got a slope of 3 over 1, or simply 3. And then my y-intercept, I can see my graph crosses my y-axis right here at 0, negative 1. So to write my equation, it would just be y equals m, which is my slope, so 3x plus b, which in this case b is negative 1, so I'll do minus 1. There we go. And that should be a nice recap about how you write the equation of a line in slope-intercept form and how you graph an equation, or a line, excuse me, given an equation in slope-intercept form. All right, so the back side, or the second page of this worksheet, is the homework assignment. So go ahead and get started on that, and let me know if you have any questions.